Welcome to our Advanced Malware Tactics video series. In this video series, we are going to dive deep into the world of process injection techniques, and this is going to be a step-by-step ascent. The first part will focus on foundational concepts of Windows, establishing the groundwork for understanding the topics that will follow. Part 2 will move into introduction to process injection, where we will cover the basics of process injection. In the third part, we will discuss the building blocks of process injection. The fourth part, in that we will discuss the different types of process injection with a specific example of QuakeBot, which is a form of malware known for its process injection capabilities. And then finally, the fifth part, we will explore the advanced new process injection techniques that were unveiled recently at the Black Hat 2023 event that happened 2 months ago. So with each video, step by step, I will build your understanding, and then by the time you get to part 5, you will be ready to dive deep into those advanced techniques from Black Hat and really understand them. So I thought of creating this series when I came across the research on newly discovered process injection methods that were presented at the Black Hat Summit some 2 months ago. Black Hat is a highly esteemed community, as we all know. They bring together several thousands of cybersecurity experts and researchers and participants from around the world. There, this security researcher, he unveiled 8 new process injection techniques which are fully undetectable, and that was the motivation for creating this video, because I wanted to take this complex high-level material produced by cybersecurity researchers at these prominent forums like Black Hat and DEF CON and translate them into simpler language with added visualization and added essential concepts that are really essential for understanding or for fully grasping these cybersecurity researches that come out in public. And the idea is to bridge the gap between the complex cybersecurity research that these researchers present and publish and the emerging SOC analysts and security engineers who are eager to learn and grasp these concepts, but they often lack the relevant cybersecurity domain experience, and that's why then it becomes difficult for them to fully grasp these cybersecurity researches. So that was the idea, to bridge the gap, to bring these researchers and these SOC analysts closer. And then also ultimately, the more people are informed about these issues, the greater the overall awareness is, and the fewer the cyber incidents we should see. So let's get started with this basics part 1 video then, where we will understand the basic concepts of Windows like processes, threads, thread pool. So let's start by discussing about applications first. So whenever you use an application, whenever you start an application on Windows, you are accessing some object like the icon of the application, the mouse cursor. All these are objects. You are accessing these objects by handles. So we will discuss about handles in this video. Then every application needs a process to start. I mean, an application will start one or more processes. A process is simply a running instance of an application. So we will discuss what a process is. And then in Windows, when you have to run a process, Windows provides the process with these worker threads who are managing this process. So we will discuss about worker threads. Then we will discuss about user mode and kernel mode, because the application, it interacts with both the user mode and kernel mode of Windows. It interacts with these different modes with the use of the APIs and system calls. So based on this, then I have drafted this agenda for our discussion. So let's get started then with objects and handles in Windows. So in Windows, you will find user level objects. Like, you will find 3 types of objects. First is user level objects, like whatever you see in the user mode, the icons for application, your mouse cursor, everything that is visible to you, all these objects that you access to do your work, all those fall under the category of user level objects. And these user level objects are provided for the users to interact with the applications. Then for the coloring and font and all these graphical display, you have the second category of objects that is called as graphics device interface objects. And then you also have the third category of objects, that is kernel level objects, because the application in the backend, it is talking to your kernel. Kernel is the core of the operating system. It is doing thread management, it is importing some libraries, implementing some importing some tokens for access control, running processes in the backend, doing thread management, using threads to execute the processes. So all these processes, tokens, threads, these objects fall under the kernel level objects category. So user level objects, you will use them to interact with the application. All the objects that are responsible for graphical display, they fall under the graphics device interface objects. And processes, threads, tokens, all these objects that are working in the backend, those fall under the kernel level objects category. And all objects, they have the system reference of handles. Every object in Windows will have a corresponding handle. So you will always find an object with a handle. And whenever a process, whenever a user, whenever any application wants to access any object, any of these objects, it would access it via this handle. So handle is, you can say, they are like system references for these objects, using which the applications, the processes will interact with these objects. So the handles and objects, this is very important if you want to understand the process injection technique. So just be clear with what handles are. And now in the user mode, you can, if you want to view the handles, then you can use sysinternal tools like Process Explorer, which you can download from official Microsoft website, and you can run it on your system, and you can choose any process. And if you click on handles here, you will see all the handles that process is accessing, and all the objects that are being accessed by that process using these handles. You will see that this is very important from cybersecurity perspective, because malicious actors, they will often open duplicate handles to various processes when they want to do process injection. So yeah, that's about the handles and the objects. And in case if you want to see the kernel level objects, which are not usually seen in the user mode using Process Explorer, then you can use tools like Windows Debugger or some other command line tools, which will help you to see the kernel level objects that the processes have opened. So that's about the handles and objects. Now let's delve into the processes, because the application, a process is just a running instance of an application. So processes can be viewed from the task manager, all the processes that are running related to an application. Now in simple terms, a process is a container which will contain these four objects. It will contain a program, a code that to execute the actual code of the application, and then it will contain this execution thread, this one worker, or it can have more workers as well, one or more execution threads to execute this code of the application. So it will at least have one execution thread, one worker who will execute this code. Then you will have the memory. Every application, every process will take a memory on the hard disk, on the RAM, and there will be a virtual address space that will be reserved for that process. So memory is required, and handles, of course, to access these objects, to interact with these objects, you would require handles. Handles are system references to these objects. So that is, in simple terms, Windows process for you. Remember it as a container containing all these objects. And yeah. Now let's look at the worker threads that are responsible for running these processes. So every process will have some threads assigned to it in order to run that process, and I am representing these threads as workers. So imagine in every process gets assigned with these workers who are going to work on that process and make sure that that process runs effectively. Now there is more to these threads. These threads, they live in a thread pool, and we will discuss now what is thread pool. We will look at the architecture a little in depth, because there are many other components that are there in the thread pool apart from these threads that are assigned to a process. So we will look at that now. So this is the thread pool architecture I'm showing you. In the thread pool architecture, you will have these three queues: task queue, timer queue, IO completion queue. Consider these three queues as three different departments in an office, and where you will have these workers working in these departments. So in the same way, in thread pool, you have these workers who are working on different queues, doing different processing activity for an application or a process. Then you also have these waiter threads, which are waiting for some kind of event or signaling to happen to start their work. These workers, they often wait for some kind of signal, some kind of message from these workers. I will explain you the working of the waiter threads with an example. For instance, consider you have a HTTP web server that is running and that is serving to the clients, and the web server is receiving a lot of incoming HTTP requests. Those incoming requests and then are received by some workers from here. Then some workers are engaged in processing those requests, and once those requests are processed, those also need to be logged into the database, right? So that's when the waiter threads will come into picture. They will wait for the threads who are processing the request to signal to them that the processing is finished. Once they get that signal that this event of processing has finished, they will start to log those events in the database. So like that, the waiter threads, they wait for some kind of signaling, some kind of event to finish to start their work, and that is why they are called the waiter threads. Additionally, you have this object called as worker factory, which is acting like a manager to these workers. So the job of the primary responsibility of this worker factory is to make sure that there are always sufficient number of threads available for running a process. So if there are less threads, this worker factory will create threads and immediately assign it from the pool to the application, the process that is running. If some thread is sitting idle, it will tear down, it will destroy that thread. So like this, the worker threads manager is managing the worker threads that are working on the process. Then you have the start routine component. Start routine component, consider it like an agenda, instructions, a list of tasks that these workers must perform in order to complete the process. So just like in an office, you have workers, they get the agenda, the instruction, the goals, the objectives from the worker, from the manager. But here there is a difference. Here this manager will not give this agenda, these instructions to these workers. This is given by the process. But this start routine, this agenda is created when the worker factory is created, and hence I have clubbed them together. But the worker factory will not manage this start routine. It will not dictate what these workers should do. It will only manage the number of workers. The start routine, that is dictated by the process, to by the process, by the application code, by the developers who have written the code. They will write the start routine for the application, for the worker threads. And then there is this last component, that is start routine value. The start routine value is the actual location in the memory where the start routine is kept for the worker threads. Consider this like a meeting room where these workers assemble every day and they get this agenda that is kept in this meeting room for them. So that meeting room number, you can relate it with the start routine value. So the start routine value is the actual address in the memory where the start routine is kept for the workers to take. So I hope with this explanation you are clear what a thread pool is, what a thread pool architecture is. By default, every process when it starts, it gets assigned with a thread pool by default. So all these components, the complete thread pool gets assigned to a process when it starts, because to run that process you would need workers, you would need worker factory object, you would need start routines. All this gets assigned to a process by default when a process starts in Windows. Okay, now system will use some system calls, some APIs in the user mode, in the kernel mode, to manage these workers, to do the process management, thread management. So the user mode and kernel mode are also referred to as user LAN, kernel LAN. Let's discuss about them on the next slide. So Windows OS, it functions in these two modes. User mode is whatever you see, whatever applications that you run, Word, Paint, browser, this video that you're watching, all this is going on in user mode. All the services, FTP, SSH, HTTP, so all that you are using, all that is running in the user mode. In the kernel mode, all the backend working is happening. That means the process management, the thread management, memory management, how much memory to give to the application, how many workers, how many threads to assign, all this is happening in the backend, in the kernel mode. And in the kernel mode, of course, all these processes, they run with higher privileges, and in the user mode, all these processes, they run with a lower privilege. So programs running in user mode, they will use system calls and APIs to switch to kernel mode. So to give you an example of this, let's say if you have to open a file on your system. Now the file is in the user mode, you see the icon for it, you double click on it using your mouse cursor, which is a user level object. You use it to double click on the file, open it. Now you are in the user mode, you have double clicked on it. Now when the file opens in the backend, the Windows switches its mode into the kernel mode. In the backend, now the application, the Windows is calling the kernel mode using some system calls and APIs to check where that file is kept, in which sector of the hard disk, and to read it and to open it and to display it for you. So like this, the Windows, it keeps switching between user mode and kernel mode. Just like a restaurant, right? In a restaurant, say the dining area where the customers, they have their food, you can say that is the user mode, and the kitchen is the kernel mode. And in order to serve you, the waiter, he has one leg in the dining room and one leg in the kitchen. That's how a restaurant operates. In the same way, Windows operates in this dual mode. Now let's as I told you that Windows uses APIs and system calls to switch between these different modes. Let's understand about the APIs and system calls. So APIs and system calls, I'm showing the doorway graphic icon here. It is not exactly a doorway, but can be considered in a simple way as a doorway into the operating system. So there are two kind of APIs and system calls, user mode and kernel mode. In user mode, you will find these Windows APIs. That is, these are some of the examples that I'm showing you for Windows APIs. Now this is not an exhaustive list, but these are some of the APIs that are really important from process injection perspective. So I have listed these APIs on the screen. Now about the Windows API, they start with this prefix like create, get, set, and they will have these keywords like create registry. If you want to create some changes in the registry settings, you will use this create API. You will use this get API if you want to read something from the file. You will use this set API if you want to make some configuration changes, update some settings in the process. And then there is this optional suffix EXAW representing the ASCII characters. So yeah, this is the Windows API. Using these Windows API, these Windows APIs are also abused by process injection techniques, and that's why we are looking at them. And then you have this kernel mode system calls, or you can also call them APIs, but the um, appropriate referencing to them is system calls. Again, this is not an exhaustive list of all system calls. These are just some system calls which are really important from process injection perspective, so I'm discussing only these. So these are some of the system calls that the kernel is exposing in the user mode, and using these system calls, the applications and processes, they interact with the kernel. Not all calls are exposed in the user mode, because the kernel has its own system calls and APIs that are hidden and that are not available in the user mode. But these are some of the system calls that are exposed in the user mode, can be accessed from the user mode, and in the user mode, the applications, they use these system calls to interact with the kernel level objects. And the prefix, they will start with NT or ZW. This is the prefix that they start with. And yeah, so that's about the Windows APIs and system calls. Just remember that APIs are like doorways, as I gave you the example of a restaurant. The waiter, when he's serving you in the dining area, he's giving you the menu card, you order something, he goes back through the door into the kitchen to get the order for you. So he's accessing the door, he's accessing some API to access the kernel and get the food for you when it is ready. So like that, in the same way, the application, it uses these system calls, these APIs, to switch between the user mode and the kernel mode. So that's all in this video then. That is the end of part 1. This is a 5-part series. There will be more videos coming in this series, but for now this is the 5-part series. So this is the end of part 1, where we have discussed some basic core concepts of Windows, which were really important if you want to understand the advanced level process injection techniques. What next? In the next part, we will now introduce the process injection. It is going to be a very short video, the part 2, where we will explore the process injection. We will take an introduction of process injection, what the technique is all about. Alright then, so if you like the videos, please share and subscribe. That will motivate me to create more videos, and then I will see you in the next part now. Thank you.